Today I'm using this ATP 641 protective coating. It's as you can see on the lid, an anti-scale coating. This is a water-based product available from Brownings. There's a US outlet and a UK outlet now. So it's water-based, so you've got to make sure you give it a good shake to get it all into solution. So your blades want to be prepared for heat treating, so they've all been cleaned up to about a 220 grit finish at the moment. It's just a matter then of they've been degreased, I hasten to add as well, and it's just a matter of painting the product on. A good thick coating. It wants to be a minimum of 5 thou according to the instructions, and I generally give them 2 coats. Quick blow with a hairdryer helps speed the process up. So when they've dried off, give them another good coating. This product, it stops scaling, which is a bit of a problem in electric kilns. Because when you heat steel above its critical temperature, the carbon atoms within the steel are free to move around. And any of those carbon atoms that happen to be on the surface of the steel will happily leave the steel to combine with a free atmospheric oxygen atom, and then that will cause your blade to become descaled. So this product stops that occurring, makes it easier to clean them up afterwards. So that's it. All the parts are, including where the cutting edges and the B and the spine of the knife, have all been coated. It's not too bad in there, so I'll go and clean it up again afterwards. But all the flats have been double coated, and then they're ready for the kiln. I've used other products as well. I've used PCB powder, and I've used boric acid, and to be quite honest, they all work about the same. They're all successful at reducing or completely stopping decarb. Well, there they are on top of the kiln now, all getting nice and warm. They're actually ready to go in the kiln. The kiln's been preheated, and they're heading now for the hot temperatures. So here we go. You don't want to stick your hands in there. So that's it. Forget the noise in the background. That's the stabiliser vacuum chamber running. So there they are. Temperature's going to climb back up, and then I'm going to leave them to soak for a period of time, and then they're going to be quenched. And as I say, when they're exposed to that hot environment in the kiln, they're not being decarbed. Quick tip on quenching blades. I'll get one out now. Straight into the oil. heavy agitation. And if you're not sure if it's cooled enough, if you get smoke coming off of it, it's still too hot. So leave the blade in, but you can see it's pulling the handle out, it's the tang's smoking, but the blade's left in, so it needs a bit more. This quench oil I'm using, it's designed for 01, and it drops the temperature very fast initially, and it drops it quite slowly. There's no smoke coming off of it now, so that tells me that blade is quenched. These are only 3mm, so they quench a lot quicker than the 4 or 5mm blades. There we go. So if you lift it out, leave the blade in, you get smoke coming off the handle there, see it? It's too hot still. Still smoking. Not smoking now. Just finished this knife for Lewis. He requested a black sheath, black right hand sheath. I've got a D-ring and dangler, new style dangler, so top opening. The knife is a Jackdaw Classic. There's a look at the flats and the bevel. There's your flats on that side and the bevel on that side. Plunge lines. Internal radii, tapered tang black liners. Stabilised walnut scales with mosaic pins. Apex pommel. There you can see the apex in there. Nicely polished spine, nice equal tip. There's the logo on the blade. So that's it, Lewis, hope you like it. Thanks for watching.